A die is thrown 3 times. Events A and B are defined as below. A is 4 on the third throw and B is 6 on the first and 5 on the second throw. Find probability of A given B, which means we need to find the probability that we get a 4 on the third throw given that we have a 6 on the first and 5 on the second throw. Pause the video, give this a try. Okay, let's write down A first. We have 4 on the third throw. This means we can have 1 to 6 on the first and second throw. So 6 options for the first throw, 6 options for the second throw, and only 1 option for the third throw. This means A has 36 possible sample points. What about B? B says 6 on the first and 5 on the second throw. This means you can have 1 to 6 on the third throw, but 6 and 5 are fixed. So this means B has 6 sample points. Now let's talk about A intersection B. A intersection B means 6 on the first, 5 on the second, and 4 on the third throw. There's only one possible outcome here, 6, 5, 4. Now to find the probability of A given B, we need probability of A intersection B and probability of B. So what's the probability of B? That's 6 divided by 216. 6 cube is 216. Probability of A intersection B is 1 by 216. This means probability of A given B is probability of A intersection B by probability of B. That's 1 by 216 by 6 by 216. This is 1 by 6. We can also solve this problem by just looking at B first. So let's forget about A and only focus on B. B has appeared first. This means 6 on the first and 5 on the second throw is there. There are 6 possible options for the third throw. Of these 6 options, there's only one that's favorable for us. A says we want 4 on the third throw. We don't want 1, 2, 3, 5 or 6. We only want 4. This means the probability is 1 divided by all of these. This is 6. So the probability that we get 4 on the third throw, given that we have a 6 and 5 on the first and second throw, is 1 by 6. Let's solve another one. A die is thrown twice and the sum of the numbers appearing is observed to be 6. What is the conditional probability that the number 4 has appeared at least once? Pause the video, give this a try. Okay, let's solve this together. A die is thrown twice. This is the sample space. From 1, 1 to 6, 6, we have 36 possible sample points. Let's first write down E, which says we have 4 appearing at least once. So we can have 4 on the first throw or 4 on the second throw. There's one sample point where we have 4 on the first and second throw. We have a total of 6 plus 5, 11 sample points here. Let's have F where we have the sum 6. This can happen when we have 1 plus 5 or 2 plus 4 or 3 plus 3 or 4 plus 2 or 5 plus 1. There are 5 sample points here. Let's write down the probabilities. Probability of E is 11 by 36 and probability of F is 5 by 36. What about their intersection? E intersection F. This means we have the sum as 6 and one of them is 4. So for this we have 2, 4 and 4, 2. Probability of E intersection F is 2 by 36. Now the required probability is probability of E intersection F divided by probability of F. This is 2 by 36 divided by 5 by 36. This is 2 by 5. Here's another way to think about it. The sum is observed to be 6, which means one of these 5 events has occurred. 1, 5, 2, 4, 3, 3, 4, 2 and 5, 1. Of these, there are these 2 events, 2, 4 and 4, 2, where 4 has appeared at least once. It's exactly once, but these are the events that we need. So the probability is 2 divided by 5, that's 2 by 5. Let's solve one more. Given that the 2 numbers appearing on the throwing of 2 dice are different, find the probability of the event the sum of numbers on the dice is 4. Pause the video, try this out. Okay, 2 dice are thrown. Let's write the sample space. We have these 36 outcomes from 1, 1 to 6, 6. E is the event where the sum of the numbers on the dice is 4. That's 1, 3, 2, 2 and 3, 1. And F is when both the dice show different numbers. So we take away 1, 1, 2, 2, 3, 3, 4, 4, 5, 5 and 6, 6. We're left with these 30 possible outcomes. What's E intersection F? E intersection F is 1, 3 and 3, 1. We don't take 2, 2. So we only take these 2. Let's write down the probabilities. Probability of E is 3 by 36. That's 1 by 12. Probability of F is 30 by 36. That's 5 by 6. And probability of E intersection F, that's 2 by 36. That's 1 by 18. So probability E given F, that's going to be probability of E intersection F by probability of F. This is 1 by 18 divided by 5 by 6. That's going to be 1 by 15. Now here's another way to think about it. Given that the two dice thrown show us different numbers, we know that one of these 30 has occurred. And of these 30, these two work for us. For these two, the sum of the numbers on the dice is 4. Now given that one of these 30 has occurred, the probability that one of these two has occurred is 2 by 30, that's 1 by 15.